In this lesson, I'd like to start getting you working with the ZPipeline values, and we're also going to work with a ZSync value here. So I'll show those in just a few moments. So as a note here, the purpose of this code is to demonstrate the following ZIO Streams concepts, including creating stream pipelines with ZPipeline for transformation and filtering. We're going to compose pipelines using that greater than operator, and I'll get into that more in just a few moments. We're going to process data through pipelines with the via method. And what I mean by that is we're going to use all these via calls right here and down there as well. We're going to aggregate stream results with ZSync. And I'm even going to demonstrate a little parallel processing of stream elements at the end. So to get started, we have the usual ZIO object, some name, extend ZIO app default. Then we define the ZIO run value here. To get started with, I create a stream right here, and we've seen that before. I call that number stream. And then what I'm going to start doing, and what we've seen in previous examples, is once I had a stream, I would start calling map and filter and map and tap for each, and other methods directly on that stream. And in this example, I did start to show via and ZPipeline methods here and here, and I covered that a little bit. Now we're going to get into that more. But typically, I just kept calling other methods like map, tap, and then even run drain there at the end. And now what we're going to do is create ZPipeline values. And I think a conceptual way to think about this is that we're just creating pure functions that work with streams using ZPipeline right here. So if you just think of double numbers as being a pure function, and all it does is this code right here, which doubles a number. So this shows the input type is going to be an int, the output type is going to be an int, and we're calling zpipeline.map, and we're just passing this function right here into that map method right there. So again, the purpose of this function is just to double every number that it's given. And that ends up creating a ZPipeline. It has this slightly different signature than what we've seen before. So the signature here is REIO. So R is still the environment, and any old environment will do. E is the error channel, and in this case, we don't produce any error, so we show nothing right there. Then the last two types are I and O. So I is the input type, or the type that we are consuming, and then O is the output type, or the type that we're producing. So here we take a stream of integers as input right here, and because we're just doubling those values, we also return an int right here. As a second example, if we look at this one, it's called convert to string, and its function says take this int right here, take this int, and then transform that into this string right here. So that's why we have an int here and a string here, is because this little function transforms an int to a string. That's where these two types come in. And again, you see those same types here. The input type is int, and the output type is string, or again, we consume this and we produce this. So this pipeline code here and this pipeline code right up here both use map, and this one here uses filter. So it has a slightly different signature right here. You can see the signature over here is still the same. It has an input type of int and an output type of int. But because of the way filter works, it's always going to return the same type that it takes in. It's not doing a transformation, it's just filtering. So if you're filtering a list of int as input, you're always going to be returning int as the output. So what I'm trying to say is that there's no reason to duplicate the type right here. So instead of having that right there, we get rid of that, and we just have the one type for whenever you're doing filtering like that. So now that you've seen that, let me recap these ZPipeline functions. So double numbers doubles every number that it's given. Filter greater than 5 only retains those values that are greater than 5. Convert to string takes an int and transforms it into a string, and it uses this algorithm right there to do that. And then this last one is called add prefix. So it takes a string and returns a string. And you can see it takes a string s and then transforms it into this new string right there, which is prepended with the result value right there. And then next up, an interesting thing is that we can combine pipelines with this operator right here. So if I scroll down here, you can see that the greater than symbol is known as the forward composition operator. I think I've seen other people call it a function composition operator, but you want to think of it as being a forward composition operator. And what forward composition means is that we're going to run this pipeline, And then we're going to run this pipeline, and then we're going to run this pipeline right here. And how that works is kind of interesting. So if I could keep that up there. The first example I'm going to show in our for expression down here is a basic pipeline chain. So we're going to start with our number stream, and then we're going to have this series of via calls right here, 4 of those calls on our ZPipeline values right there. So we're going to call the double numbers pipeline, then we're going to call the filter greater than 5 pipeline, then convert to string pipeline, and then the add prefix pipeline. And all of these ZPipelines are called with the via method, as you see in those 4 examples right there. And then the 5th line will just print that output right there. So that's the way ZPipeline values are called, as you see in these examples right here. Now this one here is called processing pipeline, and it does these first 3 calls, double numbers, filter greater than 5, and convert to string. So it's the same as that one, and that one. And we also call that with via here. So this is our second block of code inside the for expression. We start with a number stream. Then we call via, and now instead of saying do these 3 in a row, we just say call the processing pipeline because we already composed that up here. So again, this processing pipeline does the exact same thing as these 3 lines of code right there. So after we've done that, we'll just print those there. Another thing I'm going to do is show aggregation with sync. So I will double the numbers, and then you see that's called with via, and then we have a different thing here, and this is called run, and we want to run a sum pipeline. So now we need to come back up here and take a look at the sum pipeline. So this one I'm just creating with ZSink, and you can see I'm just calling a sum method on it, and I'm declaring that the type is int. So as you can guess from that code right there, we're just going to sum up all the integer values that we are given in the stream. So interesting things about ZSync, it has this type signature here, REI. RE are the same as always. Then we have ILZ. So come back to here. R is any old environment will do. E is the error channel. And again, we can't have any errors here, so we have nothing. Then we have I is the input or type we're consuming. So our input type is int. Then we'll jump over to Z, which is the last one. And that is our output type, or the type that we're returning right here. And again, since we're summing the values, we're going to return the int there. Then L is a really interesting one right there. L is this leftover type. So this is elements that our sink might not consume right there. And what happens in this case right here is that nothing means that this sink will consume all elements, and there won't be any leftovers possible. But what this does for us is allows for partial consumption of streams. So we could partially consume a stream that we're taking in, and we might have a filter method here, and we'd use that to say, oh, I just want to work with certain values, and I'll work on those, but then I'll return the other stream values for you. And if you do something like that, that's where this leftover value is going to come in. But since we are consuming all of the stream values in this code right here, we're going to be returning nothing in this example. And one other thing I need to note is that previously these are all ZPipeline values up here. So a pipeline transforms a stream into another stream. And here we're using a sink, a ZSync. And compared to a pipeline, which transforms one stream into another stream, a ZSync consumes a stream and then produces a single result value. So you can see that we're producing the single result value right here. Again, with the caveat that we could have leftover values here as well. But I do want to emphasize these 2 lines that show the difference between a pipeline and a sink. Okay, so I think we may have looked at everything so far. Let me look at this real quick. So here I have some notes about what ZPipelines are. So again, ZPipeline is a fundamental building block in ZIO Streams. They represent a pure data transformation between streams. And that's why I like to say that a ZPipeline is very similar to a pure function, because a pipeline is a pure data transformation between streams. And there's some other notes down here. You can think of it as being a reusable processing stage that takes elements of one type and transforms them into elements of another type. And again, that's like a reusable function. And then a few key points about ZPipelines are that they're composable. So they're designed to be composed together. And you saw this forward composition operator, which let you build complex transformations from simple ones. And we did that right here with these 3 pipelines in a row right there. Then we have type safety. You saw that a Z pipeline with this type signature transforms elements of type A into elements of type B with potential requirements R and errors E for that type signature right there. And then reusability. Again, these are like pure functions. So once you have defined a pipeline, you can reuse them across different streams. As long as this logic in these functions makes sense for use in different pipelines, you can go ahead and reuse double numbers and filter and convert to string. You can reuse those for any stream that you want, just like a pure function. So now I think I have covered everything. And again, this operator here is called a forward composition operator. So we'll come back up here, remembering that our data looks like this stream right here, a Z stream of 1 through 5. Let's come back to this for expression right there. Scoot that over there, and we will run this code. I'm looking at 150 Z pipelines is what I'm running here. So we'll run that. And then you see the output there. So we have basic pipeline chain. We start with that number stream of 1 through 5. We say double all those numbers in the stream, and then filter greater than 5 or retain greater than 5. So we have 6, 8, and 10 right there. Then use the convert to string pipeline, then the add prefix pipeline, and then print those out. So again, if you wanted to see convert to string pipeline, that was the one that transforms the integer n into this string right there. And then add prefix was the one that takes this string here. You see string, takes this string here and transforms it into that string. And that's why we see the result and then the number and then that value right there like that. And then the compose pipeline was our processing pipeline. So that was this one right here, double numbers, filter greater than 5, and convert to string. So we do that right there in that one step with our compose pipeline and then print those values. So you see 6, 8, and 10. And again, this compose pipeline right here is exactly the same as those 3 lines right there. We just didn't add that 4th line right there. So it's just those 3 lines. Then the next one was aggregation with sync. So you could see that we are doubling the numbers. We call via again, just like we did in these examples, and that one right there. We call via to double the numbers. And then to invoke a sync right here, we call run, and that invokes that sum right there, and then we get the sum of the numbers. So the sum of 1 through 5 is 15, and then we double all those numbers right there, and then print that sum right there. And then the parallel processing was the last one. And in this one, we start with map ZIO par. And you can see from its description, it maps over elements of the stream with the specified effectful function. So that's this effectful function right there, executing up to n invocations of the function concurrently. So n is the integer value there. And then a really nice part is that the transform elements are emitted in the original order. So even though we're running 3 parallel fibers right here, in the end, you can see the values are returned in the original order that we have. And our algorithm here is very simple. We're just saying ZIO succeed, double each number, do a little delay to simulate that we're doing some work. And then we call via and say convert those to string, add the prefix, and then print them out like we did before. So we just use map ZIO par to run this effectful function in parallel using 3 fibers right there. And that covers everything over here. So again, if we scroll back up to the top here, the purpose of this code was to create stream pipelines with ZPipeline for transformation and filtering. So I showed several versions of ZPipeline in this code right up here. Then I showed how to compose pipelines once you have them with the forward composition operator. And we showed that right here. That's our processing pipeline. I didn't show this type, but as you can imagine, it's a ZPipeline. And again, this type signature is a little messed up here. I've seen that lately with this IDE, and I hope it's just a bug. Because I didn't declare the type signature here, we get that little messed up type signature. But we can actually just copy that type signature and put that one there and do that like that, and everything should just work just fine unless I made a mistake. I'm sorry. Cannot copy that one, but I can make it that one. Save that and do that. So that fixes that little issue with the IDE and its compiler. So I just showed that. We showed how to process data through pipelines with the via method, and we did that in all of these calls right here. So you can call via on every Z pipeline that you have, and then you can call via on a processing pipeline. or a composed pipeline, I should say, right here like that. And let's see what else we have. We aggregated stream results with ZSync. So I showed how to use ZSync in this example right here, and then how to call it right here with that run method right there like that. And parallel processing of stream elements. I showed that down here with map ZIO and then our effectful function right here. And then I called the pipeline methods after we did that work there in parallel. So as always, I encourage you to get the code out of GitHub, make changes to it, play with it, do whatever you like with it until you feel comfortable with how everything works.